lots of individuals within a population, then you could say that the genetic diversity or the biodiversity within that population is also really important, is really diverse as well. And that is really, really important, because when we think about things like climate change, that increased genetic diversity can help species adapt to those changes. And this is the kind of typical diagram that you might see in a GCSE textbook or something like that, that explains what the relationships between different species are and how kind of ecosystems and biodiversity work. So, you know, we have kind of different species that prey on other ones, that feed on other ones. And together, you know, they form this system that kind of can sustain itself. So, for example, you know, the rabbits eat grass, foxes eat the rabbits. If you remove different species, then it can have a lesser or greater impact on that system. So, for example, if we took the grass away, there's nothing there. If we took away a different species, there might be a different impact. And this gets really, really complex really, really quickly. You know, if we look at a really, really simple kind of example of how the relationship between species might work, we can see on the image, there's an image on the screen now that shows kind of basically what happens with foxes and rabbits. So, you know, if you have a boom in the population of rabbits, then that will be supplanted. Later on, there'll be a kind of peak in the population of foxes to kind of protect the rabbits. Obviously, if there's more foxes, the population of rabbits goes down. So it kind of goes in this kind of gradual ebb and flow. And this is happening all the time in all the kind of habitats that we see. So this is what might outwardly look like quite a simple thing, can be quite complicated, but also, you know, quite amazing and self-sustaining as well. And this interconnectedness between species is not one-dimensional. It's not purely about predator and prey. It's about, you know, sustaining habitats. It's about, you know, kind of really all the kind of intricacies of the world that we live in. There's some quite interesting examples on your screen now. One of them is how in Yellowstone National Park in the United States, wolves were hunted to extinction in the early 20th century. Then they were reintroduced in the early 90s, and this led to loads of really amazing benefits to the ecosystem that nobody really anticipated at the time. One of the most interesting ones was how it actually improved the water quality in rivers, which led to an increase in population of fish. The reason for this being because since the 1920s, there have been no top predators for big herbivores like elk and that kind of thing. And when the wolves were reintroduced, elk became much more nervous and much more kind of, you know, less likely to loiter around watering holes and rivers and that kind of thing, which led to less erosion of the riverbanks, which meant that there was less sediment in the river, which meant that the rivers were clearer, which meant that it was a better habitat for fish. No one ever predicted that before it happened, but it did, and it just shows you the kind of these intricate relationships between species. Another one which is maybe a little bit more relevant to us in the UK is the kind of the Eurasian beaver. Actually, now we're looking at reintroducing beavers into river systems in the UK, and they act as these things called ecosystem engineers. Basically, they build dams in the upper reaches of a river catchment. These dams create areas of kind of slower moving water behind them, which create kind of more boggy kind of wetland areas. These wetland areas are really amazing, diverse habitats for lots of other species, and they also kind of soak up or attenuate water, which means that there's potentially less flooding downstream. So they're creating more diverse habitats, and they're also creating a service for us, an ecosystem service, which is something we'll talk about later on, whereby, you know, they are a natural flood defense and they might stop problems further down in a river system. And, you know, one of the things we sort of forget all the time is that, you know, as humans, we're as much connected to these natural systems as anything else. You know, we are as much part of our ecosystems as the beavers and the elks and the wolves and all those kinds of things. Just some examples on your screen now, you know, from the food that we eat to, you know, the kind of role that we play in natural cycles. So things like the carbon cycle, things like the phosphorus cycle, you might remember or know about. You know, we are intrinsically connected to these things. If you think about agriculture and you think about farming and you think about carbon sequestration and all that kind of thing, you know, as humans, we're also probably unique in our ability to kind of have an impact on the environment as well. So, you know, as you can see the two people planting a a tree in your picture there, they are they're having a positive impact on their environment doing that, but also we can have the ability to have a negative impact. And then also when we think about the resources that we actually use as well, how many of the resources you use, in your job in construction, timber being one of them, actually a directly, you need biodiversity for these resources to source them to build the buildings that we build. Even cement is you could say is potentially from fossilized sea creatures from millions of years ago. There's hundreds of examples of this. But there is an issue that we have a bit of a problem with biodiversity at the moment. And there's a recent report by the WWF that showed how really there are these series of negative impacts on biodiversity from that humans are having from changes in land and sea use. So this is where we're taking areas that maybe have good habitats, high biodiversity, and reducing them down to low biodiversity. So, for example, deforestation, something that we might commonly think about is happening in the Amazon, but the UK is one of the least forested countries in Europe. We're degrading habitats by changing a forest into kind of an area for agriculture or built up. Looking at invasive species is a really interesting one, where we have species that come in that may be from a different part of the world, and they're introduced into an ecosystem. They don't have a kind of natural place within it. They don't have a natural predator of a way of regulating their population size, so they can kind of run amok, and they can outcompete the native species that are there. Some of the most common ones you might know about, grey squirrels in the UK are not native. They've outcompeted our red squirrel in many areas. There's also things like Japanese knotweed, which can be an absolute nightmare in the UK. There's no natural predators or species that graze on Japanese knotweed in the UK, so it can run completely unchecked. Himalayan balsam is one. If you walk down a riverbank this time of year, you'll probably see it in the UK as well. They outcompete our native species, and they create a much simpler, less varied ecosystem, and one that maybe many of our native species then can't actually survive in. Species overexploitation, again, is another really, really big one. The classic would be things like fisheries. One of the really amazing things about biodiversity, if you think about it from a resources perspective, is it should be sustainable. We can consume resources that are generated through biodiversity at a rate in which they can reproduce themselves. They are sustainable. If we start consuming them at a rate where they can't reproduce or sustain themselves, then they become unsustainable. And over time, that population will go down and then won't be there anymore. If we think about fish stocks, 150 years ago, there was a lot more cod in the North Sea. It's now, they're using bigger and bigger boats with bigger and bigger engines to kind of fish cod. The cod are getting smaller and smaller and smaller. And actually, if we manage that stock in a more sustainable way, then now we probably would have more than we do at the moment. Another classic one is pollution. Pollution can be on the air, can be in the land, can be in fresh water and seawater as well. And this is where we're introducing substances that have a directly adverse impact on biodiversity in the environment, that cause species to die, or make it harder for them to reproduce, or make it harder for them to sustain themselves. An example of this might be, if you think about populations of orcas or killer whales in the north of Scotland. They haven't had offspring for I think it's since the early 90s now. It's a very dwindling population, and one of the reasons they think this might be is because over time these species have ingested lots and lots of heavy metals from a variety of sources. We really don't know quite where, and it's now at such a point where they can't actually reproduce anymore. So that population will die out because of pollution from the environment from humans eventually. It's quite sad. And then obviously the kind of big one is climate change. And this is where, by the emissions of greenhouse gases, we're creating this world in which our climate is changing. And if species are unable to adapt or move in response to this, then it will become harder for them to survive, and ultimately it might mean that some species become extinct. So again, these are the kind of 5 key points that WWF have found. WWF are kind of isolated as why we've got this problem with biodiversity at the moment and why we're seeing kind of net reductions in species. So I'd just be really interested to know, just a quick kind of poll on the chat. There was a report that WWF did, just looking at how much overall biodiversity has declined in the period 1970 to 2014. I don't know if anyone wants to guess, just in the chat, what that might be. I think everyone's done their homework. So yeah, I mean, it's quite a shocking stat, really. I think, this 60% is the correct answer. And we've seen over half the total biodiversity in the world lost since the 70s. It's the last sort of 50 years. Just really shows why we need to do something about it. And I think it's quite an interesting photo on this slide. It's a species called a pangolin. There's a very, very young David Attenborough holding it there. That was from the days when he was on a program called Zoo Quest. I think it was in the 50s and the 60s, where basically he was going out into kind of lots of tropical areas and he was showing people what it was like. I think that species was relatively common then, and now it is. Now it's a species that really is on the brink of extinction. Its scales are used in Chinese medicine. Just that shows you how things have changed in that period of time. And then my second question, and this is again, I'd like to put it in the chat what you think, but this is how much do you think insect biomass has declined in Germany between 1989 to 2013? The really important thing about this is, we're talking about insects, we're talking about the basis of those food chains that I talked about in those previous slides. The real bottom layer is the foundation of everything above. Quite often we think about kind of species higher up, the kind of fluffy, cuddly animals, the top predators and those kind of things. But really, everything is underpinned by those species at the lower levels of the food chain. And actually, without them, we've got some really big problems. So what does everybody think? You can see we've got some variety in the chat. Any more thoughts? Okay, well, I'm going to move quite quickly. So the answer is actually 80%, which is absolutely shocking. In really kind of a 30-year period, we've seen 80% loss in the total weight of insects in Germany. Again, no real smoking gun for why this is the case, which is quite scary. But we can say that, over that period, there has been a marked increase in the amount of things like weed killer, things like herbicides that we use. And, again, shows you the kind of urgency that we need to start addressing this problem. And I just wanted to show you one further slide on this, because I don't want this whole thing to be doom and gloom, but it's kind of interesting to kind of think about it and show that the urgency of the issue. If we just look at one example of a product that you could literally walk into kind of many shops and buy. So this is a bit of research that was done by Imperial College in London. This isn't a kind of fringe study done by a kind of NGO somewhere. This is a genuine bit of research. They found that in the amount of insecticide that you use in them for 1 month of a typical dog's treatment has the equivalent insecticide in it. It can kill 25 million, and that isn't the typo, 25 million bees. So you think about the amount of dogs that we have in the UK, and everyone's kind of treating it with treatment, and then obviously that washes off when the dog jumps in a river or something like that. And just quite a shocking statistic, really, that the potency of some of these chemicals that we can just buy. You can walk into a garden centre in the UK and buy a complete range of herbicides and pesticides like glyphosate. These are products that are also linked to cancer and that kind of thing as well. And in many parts of Europe, you actually can't. They've been banned. But we're just kind of slightly oblivious to that in this country. Maybe we need to just think a bit more carefully how we use these chemicals. So really, why should you be caring about this? And in this next one, I'm just going to just press play on a video. If you can't hear it, just stick it in the chat. You should be able to. But yeah, someone much more charismatic than me will give you a little rundown of what we've just been talking about.
This spider monkey is an unwitting climate activist. Large fruit eaters such as this one spread the seeds of tropical hardwood trees in their dung, helping to build up forests which absorb carbon dioxide from the atmosphere. And this is just one of perhaps millions of interactions that guarantee a healthy and functioning planet. Humans have spent hundreds of years documenting life on Earth, and we now have a catalogue of around 1.6 million species. However, there may be 7 or 8 million more that we don't yet know about. We have a good idea of the large animals, such as mammals and birds, but there are doubtless even some of these that we've missed. And the smaller you go, the more species there are left to find. As the human impact on the planet intensifies, scientists fear that many species could be lost before we even discover them. So why is it so important that we protect our planet's biodiversity? When we think of protecting wildlife, we tend to picture the superstars. But the organisms that do most of the hard work keeping our planet healthy are the unglamorous ones. This biodiversity provides us with the food we eat, from the microorganisms that enrich the soil where we grow our crops, to the pollinators who give us fruit and nuts, and the fish that are the main source of animal protein for around 1 billion people. Many of our medicines originate from plants and fungi, and many more may lie undiscovered in remote corners of the world. For instance, there's a fungus that grows on the fur of sloths that could help treat some forms of cancer. The natural world shelters and protects us too. Trees and shrubs protect our homes from flooding, and coral reefs and mangroves shield our coastlines from storm surges. And all that is not to mention the great spiritual and cultural value that nature holds for human beings the world over. But despite the overwhelming benefits of a healthy planet, many human actions are destroying biodiversity. Changes to habitats for grazing, mining and crop production, including the use of harmful fertilizers, have had a huge impact on land and sea. We hunt animals for meat and prize body parts. More than 300 mammal species risk being consumed to extinction. And then there's climate change. This affects the whole world, putting huge pressure on wildlife. In 2016 and 2017, half the corals in the Great Barrier Reef died as a result of the warming of the seas. So, what must we do now to slow down the crisis we are faced with? In addition to cutting our carbon emissions, we must find ways of using land and water that cause the least damage to the environment, leaving enough space for natural habitats to thrive. We must urgently protect the so-called biodiversity hotspots, but equally we should be rebuilding biodiversity wherever and however we can. Sometimes this is as simple as giving plants and animals the space they need to succeed, and sometimes they need hands-on management from humans. In 2020, with the help of reintroduction experts in the south of England, white-stalked chicks hatched for the first time in 600 years. Hands-on management was also critical to restoring the population of mountain gorillas in the Virunga National Park in Central Africa. This included using a proportion of the money raised through tourism to help human communities coexist with their animal neighbours. We must provide pathways for global development that work with rather than against nature, and we need to give the communities affected a seat at the table. The benefits provided by nature are indispensable for making human life both possible and worth living. We need all the riches of our living planet to help us live healthy, happy lives long into the future. Find out more about biodiversity and its importance by visiting our online Q&A. Go to royalsociety.org/biodiversity.
Okay, so hopefully you found that sort of video really good rundown of the kind of things we're talking about. And for me, there's kind of, I suppose, six key things to maybe get from the video in terms of why biodiversity is important. So there's the kind of, I guess, the human needs element. You know, we need biodiversity for everything from, you know, the food that we eat, the clothes that we wear. You know, we need biodiversity for maintaining the Earth's life support systems. So, you know, the kind of having fresh air, having clean water, having, you know, an environment that you want to live in, the mental health and all that kind of thing is really important to us. We also need it from a kind of practical perspective, looking at protection from extreme weather events like flooding, like storms, whether you're in the tropics and you've got a mangrove swamp, or you live in the UK and there's a salt marsh. You know, having that habitat there will prevent the need for a big concrete seawall or something like that. It's just as one example. You know, it's interesting when we think about climate change. There's this kind of drive for looking at kind of engineered solutions for removing CO2 from the atmosphere and looking at reducing CO2. One of the best bits in technology we probably have for absorbing carbon dioxide, trees and the natural environment. You know, if we can plant more trees, we'll absorb more CO2. We also get all the fantastic biodiversity benefits from planting native trees in the right location as well. So it's not just kind of pure removal of CO2, but also the biodiversity benefit as well. Did allude to the mental health element just a second ago, but that is really important and something that that even the NHS is now looking at, you know, kind of issuing prescriptions for people to kind of get out into nature. In Japan, they have this thing called forest bathing, where they kind of help to encourage people to improve their mental health, to go out into nature, go into forests and just be in the natural world. And the scientific research piece, you know, there's so many things that we have learned and gained from having a really amazing biodiverse world. If we think about the kind of development of drugs, you know, just another one that's recently come up is looking at antibodies that are in llama blood, actually, as essentially a kind of basis for a new treatment for COVID-19. So lots and lots to think about there. And there is this thing, you know, we kind of, I quite like it, the kind of, I guess, way of thinking about it, which is the rivet hypothesis, which is basically like, you know, the Earth is a jumbo jet that's flying through space, and as we're kind of losing biodiversity, we're knocking rivets out of this jumbo jet. You know, some rivets are more important than others. Some of them are holding the drinks trolley together. Some of them are holding the wings on the plane or the engines on. And you know, and as we're knocking rivets out, we don't really know what we can get away with and what we can't. And there is going to be a point where, you know, we've knocked too many out. The whole thing kind of crashes to the ground, unfortunately. And that's the kind of situation we're in. We're sort of blindly tapping away, and who knows what might happen. That's my kind of brief introduction. I'm going to hand over to Lawrence now just to talk about biodiversity and national highways. So it's Lawrence, I understand you're on the call. If you like, if you chat, and then I can kind of move the slides on. So over to you.
Fab. Thanks, Ross. I think yeah, I'm on. Perfect. All right, yeah, and thanks for agreeing to run through the slides for me. That's really handy. So yeah, we've all seen and listened to what Ross had to say, which is an absolutely fantastic intro to biodiversity. So thanks so much, Ross. Why it's important, what's happening to it, and how we can help it. So I'm going to take a little bit of time now just to chat through what we're doing in national highways and the sort of step change that we're involved in at the moment for environment as a whole, with our recent environmental strategy being published, and then pulling out just a small part of that strategy, which is obviously very important to biodiversity, which is our biodiversity key performance indicator for the next road period. So we have next slide, please, for us.
Excellent.
Lovely. Yep. Yeah, thanks. I probably shouldn't have had two intro slides, but this is this is the first part of the talk, which is on our environmental sustainability strategy, the ESS. And as I said, this is a bit of a step change from just thinking about the environment as something that we should mitigate for the issues that we might create, or try and reduce those issues, and kind of seeing the environment as a constraint to delivering our core project. What the environmental sustainability strategy, published in May this year, goes beyond that to say is that actually we should be designing good environment into schemes from the outset, making it part of a deliverable for a scheme rather than just an opportunity cost, really. Next, please. I think actually it might be something that pops up on that. Yeah, lovely. So we've got a little quote here from our Director for Environment, Steve Elderkin, who says here, and this is in the sort of preface of the strategy, our environmental performance is of national significance, and we're setting ambitious, credible plans to achieve net zero carbon, be positive for nature, and to reduce our environmental impacts on communities. As Ross mentioned in his slides, these things aren't disparate. They're not separate. We improve our communities where we improve nature. We can address net zero where we improve nature and increase biodiversity. There is a connection with all of it. And exactly as Ross says, you know, we've got carbon cycles, nitrogen cycles, we've got food chains. None of these exist independently of what we do. We're an integral part of all of them. Next slide, please, Ross. Okay, so within this strategy, we've got three main pillars or themes, which are nature, carbon, and communities. These all coalesce around our little sort of buzz term, which is a connected country, a thriving environment. Most of us on this call have probably worked with around highways for long enough to know that ever since Highways England, we've talked about a connected country being integral to our delivery. Obviously, that's what the roads do. They connect areas. And we've really picked up on this in the environment strategy to say that connected country isn't just for humans, it's for everyone. We're not just connecting A to B across the road, along the road. We should also be thinking about connecting communities across the road, connecting habitats across the road. And that's picked up in that sort of tagline. So yeah, three pillars. Nature. I think we've got probably a good idea about what nature is from Ross's slides earlier. Carbon, again, it's hard to exist in this world at the moment without thinking about net zero or hearing about net zero. And the carbon pillar is all about our plans for net zero by 2030, 2040, and 2050. And then the final pillar is communities. So this includes some environmental topics, which I'm sure we'll all be aware of things like air quality, noise, cultural heritage, landscape, anything that really directly affects the communities and the people living around our road. Next slide, please. Okay, so we're getting further and further out. This is, I think this is the final layer of this circle that I'll be chatting about in terms of the ESS today. So we've got our tagline, we've got our three pillars, and then around that we've got our priority areas. So you can, I'll let you all read what these priority areas are, but they're not necessarily, these are three for carbon, these are three for nature, these are three for communities. We appreciate that these priority areas will impact, affect, and hopefully enhance all three of these areas. So there's things in here like cleaner, quieter journeys, leaner construction, all fantastic stuff. There's some more nature-related ones, I suppose, that are a bit more relevant for the call in terms of integrating our network with the wider landscape. So that's connecting environments across our network and with our network. We've got nature-based solutions. Nature-based solutions, for those who may not have heard that term before, you definitely would have heard of nature-based solutions before. So these are things like using reed beds to mitigate for pollution in a watercourse, or potentially where we have effluent that would go straight into a watercourse. You can use reed beds and other habitats to clean that. Other nature-based solutions are things like using a green roof instead of a normal roof. That's great. It actually slows down some of the runoff as well, and it provides some biodiversity and some carbon benefits. Lots of different nature-based solutions, and it's an area that we're really actively exploring. All of these things just take inspiration from nature with the nature-based solutions. So there's something else called natural flood management, which basically does exactly what Ross was saying the beavers do in one of his earlier slides. So we can either introduce beavers to do that, or we can create the habitats ourselves. Both are kind of nature-based solutions to a flooding issue. Next slide, please. Okay, so the second part that we'll talk about now is one of the actions that's within the plan, and this is our biodiversity key performance indicator for RP3. So I think most people will understand our sort of funding road periods on this call for highways, but we're funded in 5-year periods. We're currently in road period 2, or RP2, which is 2020 to 2025. And then we'll be moving from 2025 to 2030, we'll be in road period 3. So this is our new key performance indicator for that next 5-year period, which we've coined net positive for nature. And yeah, lots of flowers around everything that we do at the moment for this net positive for nature. Next slide, please, Russ. Okay, what does net positive for nature actually mean? It's a term that we've coined for the strategy, and it takes into account some different sort of goals for biodiversity that you can have. These 2 goals are called biodiversity net gain, which people may have heard of, and biodiversity no net loss. I'll cover what they mean broadly later, but they are basically accounting for biodiversity, giving biodiversity a number, and then thinking about the projects and the actions that we do and how they change that number. So in very broad terms, biodiversity no net loss is similar to net zero for carbon. It is having a neutral position for biodiversity. Anything that we destroy, we put back, and we get zero change for biodiversity. Biodiversity net gain, as you can probably guess, goes beyond that and delivers at least 10% more biodiversity than when we started a road project, an investment period, any action. You can work out the biodiversity costs and benefits of the changes in those numbers and get 10% more if you put more habitats back in. So net positive for nature for us as a company, for National Highways, looks at 3 main ways in which we currently impact, deliver, take away biodiversity. The first, and probably one of the largest impacts that we can have on biodiversity, is with our new projects. So going through our major projects. And this part of our company for RP3 will have a biodiversity net gain target. So every project that delivers in RP3, so 2025 to 2030, will have to leave 10% more biodiversity than it started with. This also aligns with government policy and government legislation in which some of those projects will already be picked up by 2025 as having a legal target to do that. All of our projects that require DCOs, so our nationally significant infrastructure projects, will require this by law. All of our slightly smaller Highways Act projects won't, but they will now be required by our key performance indicator. The second area is actually at the bottom of this chart, that has a very large impact on our biodiversity, is how we run our network and how we run what we call the softer state, which is the verges around our network. And for RP3, that will have a target of no net loss of biodiversity. So anything that we do to our operational asset on the verge, we will have to make sure is neutral for biodiversity. This takes into account how much we're maintaining that asset. If we don't maintain the asset for any number of reasons, then we will have to offset any assumed loss from the lack of maintenance. For areas that are maintained, we won't have to assume that if the maintenance is up to scratch, and there will be areas which come under operational renewals, or just have a really fantastic maintenance plan, which are actually delivering biodiversity benefits, and they can offset some of the losses. The third delivery area for net positive for nature is within the department that I'm in for National Highways, which is SES. And within SES, we mainly have central roles for advising the business, but we've taken this target on board in this road period, and we will do in the next road period, to deliver some large-scale schemes with third parties. So working with parties like the Wildlife Trusts, the National Trust, we work with a charity called Plant Life, and many others, where off the network, we're delivering some large biodiversity enhancements and improvements. And again, the units of biodiversity that we generate from that can help us with our major projects and our operations in case there are any losses that we need to offset. Next slide, please. Okay, so there's a few slides on what it actually means. I will go through this quite quickly because some of them are probably a little bit detailed. This one's quite high level though. So what is biodiversity net gain, biodiversity net loss, biodiversity metrics? So biodiversity net gain, as I said, is at least 10% more after you've done the project. Biodiversity net loss is neutral. They're all measured using something called a biodiversity metric. These metrics are owned by central government. So the current one is owned by DEFRA. And it is basically an Excel-based calculation tool where you chuck in what habitats you've got, how big they are, what condition they're in. All of these are done from ecological walkover surveys before you do the project. That pops out a number of the biodiversity value of the baseline of your scheme. You then put in your design into this to say, okay, we had this much woodland, this much grassland. After the project, we're going to have this much woodland, this much grassland, and this is our number. Generally, if we're not thinking about the designing for the metric, that second number will be lower than the baseline. And then we have to start thinking about, okay, so can we put some higher value habitats in than we would have normally? So chuck in some more biodiversity in a smaller area, because generally we've turned something that was, at least for an offline scheme, we've turned something that was a green field into maybe a concrete road. Luckily, that green field didn't have much biodiversity value, but it had a lot more than the road does. So what we can do here is say, okay, we're losing biodiversity from tarmacking over that field, but we're planting a woodland next to it. That woodland, when it's fully grown, will have a lot more biodiversity than that farmer's field ever did. And that's how we can play that calculation to get those gains out. These calculations do allow for times as well. So obviously in 30, 40, 50 years time, there'll be some sort of woodland, but until then it won't be. So there's a bit of a discount factor you have to apply to say, actually, we need to put quite a bit more woodland in to cover that period. And so, yeah, these biodiversity metrics provide biodiversity units, and that's the currency of biodiversity net gain. Very similar to carbon credits. Next slide, please, Russ. Okay, so this is a bit that people may be slightly more interested in terms of thinking from a project level, is actually how can we deliver against something that is actually quite a stretching objective of the company to deliver biodiversity net gain in some areas and no net loss in other areas. We've got something called a delivery hierarchy, which is very similar to mitigation hierarchies that you would have heard of before. So the most famous example of one of these hierarchies is in waste with reduce, reuse, recycle. This is very similar in terms of the reduce is to avoid the biodiversity loss. And then we've got reuse, recycle split into many other stages down here. So we start off when in designing the project, looking to how we can avoid the loss in the first place of biodiversity. So that might be when we're having a scheme design, we look to plonk the road on a field rather than an ancient woodland that's worth loads for biodiversity, or rather than a watercourse that's also very highly valued for biodiversity. That's that avoid and kind of covers minimize as well, in which we're trying to avoid and minimize this damage by either plonking the road in a totally different area or slightly tweaking the design to avoid the high value assets. Those are avoid and the minimize. From there, we look to restore. So actually within our project boundary, there may be some habitats that aren't in the best condition. It could be a woodland that has been very poorly managed, or it could be a meadowland that has actually just scrubbed over into bramble, which is worth less for biodiversity than the sort of flowering meadow was in the first place. And we can look for these areas along our scheme boundary that have a lower value than they should. And those are really easy wins to just then start to restore, put appropriate management practices in place and really increase the biodiversity that way. If none of those things are possible, or where we've exhausted all of those options, we then start thinking about creating biodiversity ourselves. This is tricky and it costs a lot more than the other steps. I mentioned earlier that the metric calculation gives us these kind of unfavorable discount factors where we deliver something new because it takes so long for that habitat to turn into something with biodiversity. And this is where we start to get hit by those. So yes, we can plant a woodland, but as I said, it's going to take years to come into effect and become a woodland. And therefore, when you first deliver it, it's worth about a tenth of a already established woodland. So it's hard to claim many units from that area. You have to deliver quite a lot of it. Also, obviously, it's also more expensive to plant a woodland than it is to just change the management regimes on a meadow. So all of these lower down actions on the mitigation hierarchy are expensive and they don't give you as much. But if you can't do the others, then you have to go on and do this. So creating on-site within our boundary, creating off-site, so just outside our boundary, or working with third parties like we do with the Wildlife Trust. And the final option to us is, at least for where we have a mandatory requirement to hit biodiversity net gain, we can buy credits from the government. They are ludicrously expensive in relation to any of the other steps. So I think, to put it into perspective, something like if we were trying to sort of offset a hectare of meadowland that we'd gone through, that would cost us somewhere in the region of, I think it was something like 120k or something, which if we just change the management process in a meadow next to it, it would be a lot cheaper than that. Next slide, please. Okay, I will go through these quite quickly actually, because I appreciate there's a few questions and we don't have very long. So this is just going through these steps in a bit more detail with some pictures. So yeah, avoid, you can see, you don't chop down that tree in the first place. You move the road into the area where there aren't the trees. Next bit, please, Russ. Then we have restoration, which is look at the habitat, see if we can make them better already, which already gives us a plus, which allows for a negative elsewhere. Next slide, please. We've got habitat creation. This requires whatever was there in the first place to be destroyed. So it could have been a low value habitat. So it could have been a low value grassland that we turn into a meadowland. Actually, to do that, we have to pull up all of the grasses that were there, or else they'll outcompete. Similarly to how Russ was talking about Himalayan balsam and other over-competing plants. If we have an area that's not very biodiverse for grassland, something a bit like a lawn will generally outcompete the flowering flora that we care about for biodiversity. So we have to rip up that whole area, reduce the soil fertility, and then plant the meadow. So we get a bit of a loss first, and then we get up to gains. And that's why creation is a bit further down in that hierarchy. Next one, please, Russ. And then the final point that I was talking about, where as SES as a whole, and all projects can do this as well, we look for third parties to help deliver our schemes with as well. And we've had lots of successes working with people like the Wildlife Trusts, who generally have a lot of skills in-house and a lot of motivation to do some of these works, but don't necessarily have the same levels of funding as we do. So we can actually deliver quite a lot of biodiversity with them before having to go and buy credits from the government, which again are very, very much more expensive than working with these charities. This can also, you can work with partners. They don't have to be charitable organizations. You can work with landowners around a scheme. So farmers or other large landowners around a scheme can also help deliver these things for cheaper than buying that credit. Next one, please, Russ. So then there's a couple examples here, and then we can take questions of projects that have done really well with this. So the A30 Chiverton to Carland, down in down in Cornwall, bid for quite a lot of funding through the Environment Designated Fund in National Highways to look at a sort of landscape scale habitat enhancement around that road. There's lots of biodiversity around that area of Cornwall, and actually the road itself kind of cut through, segregated and separated any of the habitats linking together. So therefore stopped really any of the species from going either side of the road. It was a big wall down that part of Cornwall. So what this project has done is develop something called green ribs, which are connectivity structures. They could be green bridges, they could be underpasses, they could be greened standard bridges. So where we have access bridges for farmers, we could put something green on there, plant something green without a massive design change to allow movement across the road. So like with all of these things, the more people you get involved, the better. So the project itself worked with ARUP, Cornwall Wildlife Trust, Cornwall Council, and some other local organisations to deliver this with buy-in from local stakeholders. Really, it definitely helped the scheme with local stakeholders. It also utilised community-generated ideas, so it had lots of stakeholder events saying, "This is what we're thinking. How do you feel about this? What biodiversity do you think we should prioritise in this area? Also, what connectivity could communities benefit from in this area?" And bringing it back to what I was saying in the ESS and that third pillar, which is all about communities. Next slide, please, Russ. Okay, so yeah, the information on this A30 scheme, just the Green Ribs part of it, they planted 13,000 trees across 5,000 hectares. They connected up 32 distinct habitats, and they've got a 97% biodiversity net gain. So you may remember from earlier, I said we're looking for 10%, and some schemes, they got 97%. So it can be done. They found it quite easy in that area. They also got a 242% increase in hedgerow biodiversity as measured by their hedgerow metric, which is absolutely huge. And it all connects to net zero as well, because there was lots of carbon sequestration from all of the natural habitats. And I think we've got one more slide and then we're done. Actually two, sorry. So there's lots of challenges, challenges with working with local communities, getting them on board, having the right agreement set up with third parties where you want to deliver some of these areas, making sure that you're sure that they will be delivered and these habitats will be monitored and maintained, being realistic whilst being enthusiastic, all of these points. For whenever we try and go beyond in a project, these points are probably all true. And then final slide, please, Russ. So what else can projects use to get an idea about the impacts they're going to be having early on in a project, or what the local wildlife and habitats look like? Within the spatial portal, which is National Highways' sort of GIS platform, which is open to all of NH's supply chain, we've got some great remote sensing based maps that basically say these are all the habitats on the network and a kilometre either side of the network. Like I say, that's open access for anyone within National Highways or their supply chain. And it's a really great tool when thinking about and designing projects or thinking about where we can increase biodiversity on or around our network. Lovely. Only 8 minutes for questions. I'm really sorry about that. But that's the slides done. Over to questions.
Thanks, Lawrence. It's really useful. And yeah, I think what we'll do, I did have a few more slides in my deck, but as we only have about 8 minutes left, I'm going to open.
Oh, sorry.
No, it's absolutely fine. It was really good and and actually a lot of in the content I was talking about anyway. So things like hierarchies and next page. So that's fabulous. So I think what we'll do is I'm going to stop sharing and I'm going to go through some of the questions that we have on the chat. So question for National Highways, Lawrence. What responsibility does National Highways have for the maintenance of off-site created habitats?
For off-site created habitats?
Well, I suppose on and off-site. I know.
Yeah.
It'd be interesting to give an overview, because I know it's a really key thing with net gain around, when you do end up creating or having a management, let's say, a management obligation. How does that work?
Yeah, so it's definitely an area that we're getting pushed to do more, and we're actively trying to do, wanting to do more, and are doing more in this area. I think historically, large infrastructure hasn't been great at maintaining the assets that it puts in place in a new scheme. So we've had, we had environmental impact assessment around now for 50 odd years in some form. I think in the early days, there wasn't enough bite to enforcing that once a developer had developed an area, it maintained that area effectively. It's an area that is improving. There's environmental improvement plans from DEFRA and the Environment Act, which came about a couple of years ago, and that puts a lot more of a legal duty on us as a landowner to ensure that we maintain our habitats to their appropriate standard. So there's something called the NERC Act duty, which has been massively increased in its bite and in its teeth, really. And as a developer and as a large landowner, we now will have to report on our biodiversity in regular periods to show how we are maintaining it. As a company, we're taking that a lot more seriously. We've got this environmental sustainability strategy, and we also have an internal document called the Softer State Asset Class Strategy. And this is where we push that our maintenance contracts match up with our aspirations, so that where we do put new habitats in place, they are maintained, they are monitored, and if they fail, they're picked up and they're re-enhanced again.
And isn't there a thing with net gain where if you are looking to get the kind of 10% statutory net gain, it's actually, those habitats need to be guaranteed for 35 years, as I understand it.
Yeah, you're totally right. Yeah, 30 years is the legal minimum that habitat has to be around for, and you have to show that you've got, exactly as you're sort of alluding to, you have to show that you've got legal contracts in place to ensure that that is deliverable, and we also will have to monitor those areas, as all developers will, and report back to DEFRA every 3 to 5 years.
Yeah, and I guess just for the audience on this call as well, that'd be something that you'd be looking to collaborate with your supply chain to make sure that happens, and there'll be, obviously very responsibilities and people involved in that to make that happen.
Yeah, exactly. Every new scheme will have to have a management and monitoring plan in place, which is a legal document that's required. That will work in tandem with something which our supply chain definitely would have heard of, which is our environmental management plans.
Yeah, so the question on biodiversity units as well, and just around, kind of the measurement of biodiversity units and the difference between new trees and established trees. And obviously, I think it's probably a few things to unpack from that there is this thing called the biodiversity metric. I think version 3, I think at the moment, that DEFRA are in control of, and it's essentially, you get this baseline. So essentially, like Lawrence talks, we have this walkover survey where you'll assess what habitats you have on site, and there are very elements that will be assessed at that time. So things like habitat, what you've got, the significance of the habitat, the condition of it, and that will need to be done by an ecologist. And then once that assessment has been made, then you'll have to look at, well, what's it going to look like in the future as well. And in terms of, looking at new trees and established trees, and again, Lawrence, you might know a bit more about this than me, but basically it will just be, in some ways, the condition and the type of habitat. So you have trees that have been there for a long time, that's going to be potentially ancient woodland. That's going to have a much higher biodiversity rating than something that's kind of scrubby woodland. There's also this other thing with net gain, that it's not a replacement for the existing statutory designations that we have. So it's not something that's coming in. We're still going to be talking about triple SIs. There's still going to be habitat that is kind of off limits for net gain because it has, irreplaceable habitat. So these kind of habitats that are protected will still be protected, and it doesn't give a license to kind of come in with a JCB and a chainsaw and get rid of those places. So I don't know if you've got anything more to add on that, Lawrence.
Yeah, no, nothing really to add. But yeah, no, you've voiced it very well, Ross. That there's a huge concern that when you just put something into numbers, it gives you a license to trash as long as you bring your numbers back up. But yeah, it's a really good point to make, that there's loads of other legal protections for areas, and this doesn't come at the cost of any of those. It is an add-on.
And another question: are you looking at initiatives like green bridges to reduce the impacts of roads and sort of improve habitat connectivity?
Yeah, so one of the key sort of priority areas of our environmental sustainability strategy is around connecting habitats and also connecting communities at the same time. Green bridges is one example of a method of connecting those areas. It's the most expensive way of doing it. We have a few of them around in our network, and they are very expensive. There's other structures. There's greening existing bridges, which kind of is a slight difference to green bridges. There's also putting wildlife underpasses in place. So as part of the deliverables of this environmental sustainability strategy, in the next, I believe in the next year, we will be exploring further where on our network we could put structures in place. And then within our next road period, we will start delivering structures, some of which may be green bridges, some of which may be others, because you can probably get about 20 wildlife underpasses for the same price as a green bridge. So we'll be weighing up the options and the sort of cost benefit of all of those options.
It's really interesting. I mean, I think it is one of these things that just from perspective of the supply chain school and myself as well, working across various sort of clients, various sectors, but the kind of linear infrastructure like rail, like roads. There's lots of really amazing opportunities because you do have this estate that you kind of don't necessarily realise that you've got these verges, and there's, as much as you've got these linear assets that can kind of divide habitats. Obviously, habitat fragmentation is an issue. There's all this really interesting ability to kind of connect things together as well, and now increasingly some organisations are looking at potentially if they are creating habitats in certain areas, or if they have got protected sites that they're passing nearby, actually looking at establishing habitats that can kind of reconnect those areas together can be really interesting. So
Yeah, you're really right. There's most of what I've talked about is, I suppose, transverse connectivity and segregation that the roads can cause. But there's a huge potential, as you say, in the sort of longitudinal connecting. We already have an asset that's connecting two towns, two cities. It could probably connect some habitats that way as well. And it's definitely worth remembering that we're a longitudinal connector and and a transverse segregator.
Yeah. So I mean, obviously with that, I mean, I think just one more. I know we're at time, but I'm just seeing funny about green bridges, except they are going to be expensive. Yeah. Are you going to actively monitor the effectiveness of various solutions for connectivity? It's a bonus question. We're over time, but
It's a fantastic question. So yeah, like I said, we've got a few in place already on our network, and we're looking as part of that. Where's the best place for the right asset to be? We're also looking into the effectiveness of the assets that we already have. So yes, there's one up in near Manchester in the A556. There's one down in Kent on the A21. These are those are our sort of two big green bridges. There's a few elsewhere. M25 junction 10, so where the A3 joins the M25, we're also going to be delivering one. We're going to be looking into how effective they are and doing sort of post-op opening studies to understand were they the correct asset and what can we learn from them.
fabulous. Well, with that, I think we're over time. To say to everyone, thanks very much, Lawrence, for joining the call. I think it's been really fascinating to hear from National Highways and what you're doing, and to get that kind of real view from the sharp end about what you're doing about biodiversity and that going, really interesting.